Very good morning, my dear students. Today we will solve a big game method problem. Okay, in module 2. So far we studied about the simplex method problem. Okay, almost I solved 3 to 4 problems. So procedure is same for this problem also, but something different. Okay, as the name indicate, big game method, we have to choose the variable along with artificial quotient is m. Okay, that is a different variable. That is a little different procedure for solving this type of problem. Okay, so question is given like this: solve the following linear programming problem by using big game method. So in module 2 almost all the problem question is same, but in examination be careful. You have to study what the which method is asking, just you observe in the question. Okay, so in previous problem also its question is same, so but method is different. That is only the normal simplex method, but here they are asking big game method. Okay, so here the question given z of minimization. So minimization problem is given. Okay, minimization is equal to 5x1 plus 6x2 and is subject to a constraint of what, 2x1 plus 5x2 is greater than equal to 1500 and 3x1 plus x2 is greater than equal to 1200. Okay, and where x1 and x2 is greater than equal to 0. So this is a question they given around 14 mark question, they may ask you direct. So this is with the help of big game method we solve the simplex method problem. Okay, so first step is to convert, first step is to observe which problem is given, whether it is belongs to minimization or maximization, and right hand side is all should be value positive. Okay, so the question z is given minimization and right hand side is all are positive, and along with that we have to check the sign also, very important. So here in the sign is greater is given greater than equal to, greater than equal to. For greater than equal to sign is given, then you subtract the surplus variable s1. Okay, now surplus variable is called denoted by s. Okay, along with that you have to add the artificial quotient, artificial values variables, so in big game method. Okay, now that is procedure is there by who this man is invited. Okay, so first is you convert 2x1 plus 5x2 minus s1 plus a1 is equal to 1000. Write the given equation in terms of subtracting surplus variable and add the artificial variable. Okay, so I will repeat here. First equation, so 2x1 plus 5x2 minus, why you are here why are putting minus, because sign is greater than is there. Okay, if it is less than means you add the plus sign. Okay, minus s1 plus, along with that artificial a is all called as artificial coefficient. A1 is equal to 1500 and 3x1 plus x2 minus s2 plus a2 is equal to 1200 is given. Okay, for the minimization z is equal to 5x1 plus 6x2 plus that you convert these two in the equation in the form of minimization. Okay, that modified equation is that is equal to 5x1 plus 6x2 plus 0s1 plus 0s2 plus ma1 plus ma2. So where a1 and a2 are called as artificial variable. Okay, m is that method is big game method, so just along with that quotient to consider as m, and s1 and s2 their quotient is 0. If you are multiply with 0 means anything, you are not getting anything. Okay, that is equal to 0 only. So right, minimization is equal to z of 5x1 plus 6x2 plus 0s1 plus 0s2 plus ma1 plus ma2. Okay, now this is the modified equation. This is the first step. Okay, to solve big game method. Okay, so second step is to, by with the help of this variable you have to take the you have to construct one simplex table variable. Okay, so here how many quotient are there, so just to construct one table, it's table is same for all the problems, all the methods. Okay, write down here cbi means basic variable coefficient, so bv means basic variable or basic value, right? And upon the top one is cj is equal to coefficient of variable, and this side is solution ratio, and in between these variables, so minimization equation variable. Okay, here minimization variable I given here, minimization variable is here what they given, 5x1 plus 6x2 plus 0s1 plus 0s2 ma1 m2. So x1 x2 s1 s2 a1 a2 is the minimization problem here they given here. Okay, so here x1 x2 a1 a2 that you have to write, upon which that coefficient of x1 is 1, x1 coefficient is for you 6 0 0 a m. Okay, x1 top one is you write coefficient of that, for x1 coefficient is 5, x2 coefficient is 6, similarly you write down. Okay, so here basic variable you write. In previous case what we added in slack, that is we are adding slack variable, that is s1 and s2, but here we are adding artificial quotient in the basic variable column. Okay, that is a different procedure, that is the only different, a1 and a2. Along with that in cpi write the coefficient of a1 coefficient is m and a2 coefficient is m. So in between in these values you write coefficient of that. In the equation they given x1 coefficient is 2 right here 2. X2 variable is what, 5 is there, write 5. S1 is -1 is there, right, -1. S2 is not there in this equation, right, 0. And A1 and A1 is 1 and A2 is not there, right, 0. Okay, and equation is 1500. Similarly you write X2 equation. Okay, X2 is also here they given 3 1 -1. A1 is not there, 0 and 1, that you write, and 1200. Okay, so after this you need to calculate zj value. How to calculate the zj value is m into 2 plus m into 3, this cbi into this values. Okay, I wrote here m into 2 plus m into 3 is equal to 5m. So m into 2, one example I shown here, m into 2 plus m into 3 is equal to 5m, right here. Similarly next column, m into 5 plus m into 1, that is you will get 6m. M into -1 minus m into 0, you will get minus m, right, like that you write here all the variable. Okay, so after this, after calculating the zj values, you need to calculate what, cj minus zj value. So top is there cj values, and bottom we calculated the zj values. Okay, so zj is equal to 5 minus 5m, you write my 5 minus 5m, 6 minus 6m, my 6 into 6 minus 6m, 0 minus minus into minus plus m, write down, like that you calculate the cj value. So after calculating this, you check whether the given solution is optimal or not. So if it is optimal, all the cj and zj value should be either negative or 0. Okay, sorry, either positive or 0. So here this is value is negative is there, this is value negative is there, so solution is not optimal. So this m is positive, m is positive, 0 0 is correct. So for that you construct a second table. So again you go for the second simplex table. Okay, for the second simplex table, how to select means, so least negative value you choose from the minimization among the cj and zj value. So 6 minus 6m is the least value, I shown here arrow mark, also put it on circle. Okay, so respect to column, along with that you just want draw in rectangular box. Okay, 5 is 1 and x2 is a put it rectangular box. Okay, after selecting this, go for the horizontal way. So here they given 1500 and 1200, divide by that selected column. 1500 divided by 5, you will get 300. Okay, 1200 divided by 1, that is selected column, you will get a 1200. Okay, after calculating this side, you select the least value among the ratio. Okay, among these two least value is 300 is there. So 300 column you select it. Okay, put it on rectangular blocks from 2 to 1500 full. Okay, I shown here. So after calculating this, this what we selected along the column, it is called as a key element column, and row is called as a key element row. Okay, that one digit will be intersection between these two, that element, that digit is called as key row. Okay, so after calculating this key row intersection, we need to calculate what, construct a next table, simplex table 2. Okay, for this here x2 where the light point is intersection is there, no. So for that you have to x2 is entry for that particular, and selected row is a1 is leaving. So for constructing second table, you will get x2 and a2. Okay, x2 is the entry, a1 is leaving. So a1 is leaving is there, to scratch it here. We don't want the next cycle for the next table. Okay, so I hope you understand this. Okay, for constructing second, so write divide for the key element divided by all the element divided by key element, all the values. 2 divided by, here the first element row is 5, key element is 5 is there, so 2 divided by 5, you write here 2 divided by 5. Okay, next 5, our aim is to make key intersection element is 1. So for that we are dividing the all the element. Okay, 5 by 5 you will get 1. So minus 1 by 5, 1 minus 1 by 5, 0 by 5, you will get 0. And the last one is a1 is related because it is a leaving variable, so 0 by 5 equal to 0. Similarly for a2 value entering, you have one formula. According to that formula you have to enter. So formula is there, only the key intersection element only you divide by that procedure. So remaining value enter by this formula. Okay, old value formula is old value minus corresponding key column into corresponding key row divided by key element. Okay, so here I will show one. So old value for the previous table, that is 3 is there here in place of a2, that is in x1 3 is there, minus corresponding key column, corresponding this key column is 1 is there, right here 1. Okay, and corresponding row value is 2 is there, 2 divided by key element is there 5, right here 5, you will get 3 by 1 minus 2 by 5 is equal to 15 minus 2 divided by 5, you will get 13 by 5, right here 13 by 5. Similarly for the second also, you have to calculate with the help of this along all the a2 values. Okay, now once you calculate this, calculate the zj value is same, 6 into 2 by 5 minus m into 13 by 5, you will get a 13 12 plus 13 m divided by 5. Similarly you will get like this. Okay, now this into plus this. Okay, you will get this 12 plus 13 by m. So I will repeat here, 16 into 2 by 5 plus m into 13 by 5, you will get 12 plus 13 by m. Similarly we will get 6 into 1 plus m into 0, you will get a 6. Okay, like that you calculate. Once you calculate zj values, go for cj minus zj value. Okay, cj minus zj value, how to calculate cj minus zj? Same. So top is given cj and zj, 5 minus this 12 plus 13 by m, you will get a 13 minus 13 m by 5. Similarly calculate all cj and zj value. So to check the, after calculating the cj and zj value, you check whether the given solution is optimal or not. If it is optimal, all values for cj should be 0 either positive. So this is positive, this is positive, this is positive, but this is the, and this is one is the negative is there. Okay, and this is also negative is there. So for that again you have to go for the consider the second table. So I solved here how to solve that plus 12 m 13 m, I solved here in this ppt. Okay, I'll check it later. So here so again select the least highest negative value. So this is the highest negative value. So respective column you draw in rectangular blocks. Along with that again 300 and 900 is there. 300 divided by 2 by 5, you will get 750, and 900 divided by 13 by 5, you will get 4500 by 13. So again one line will be there, one point will be intersecting. So 13 by 5 and this is 2 by 5. So this 13 by 5 this x1 is here, x1 is entry and a2 is leaving. So a2 don't treat for the next table. Okay, you have to delete. So x2 by x1, and you follow the same procedure, you will construct this next new table, that is simplex table 3. Here x2 by x1, same procedure you follow for the x1 divided by key element. So here key element is 13 by divided by 13 by 5 equal to 1. 0 by 13 you will get 0. Okay, so like that you calculate, and this side also calculate. Okay, next is calculate the zj value. Same, 6 into 0 plus 5 into 1 is equal to 5. Same procedure you follow what we solve, how you got the simplex table 2. Okay, so for you here 6 minus 1 minus 1, a2 we don't want to delete it, that is nothing is there. Again cj minus z is equal to, top is there 5 minus 5 is equal to 0, 6 minus equal to 0. So like that you do cj minus zj value. What if the, for the minimization problem, cj minus zj should be possible optimal only when all the cj and zj value is equal to 0 and plus. So we got all here plus values. Okay, now so thus for here the solution is optimal, hence you write here on answer here all the cj minus zj values are 0 and positive, hence the solution is optimal. But how to write answer? So here x2 is 2100 by 13 and x1 is equal to 4 here 4500 by 13. Okay, this is the answer, and zj value is equal to 2700. Okay, now so how to got 2700 means I wrote here z is equal to same this into this plus 5 into 4500 divided by 13, you get 2700. Okay, so at this condition the solution is optimal. Okay, so this is about the procedure for solving the big game method. Okay, procedure is same, but beginning it just is a little different. So I hope you understand this. Thank you.